So today we're going to be talking about the distance formula and how to use it within your homework. So the distance formula can be found in Chapter 1, Section 6 in midpoint and distance in the coordinate plane. It's within page 43 and to 49 in your geometry textbook. So if you happen to be in my geometry period number 6 class, it's listed as homework number 5 on Zangle. If you're in my geometry period number 4 class, it's listed as homework number 6 on Zangle. So your distance formula is right here. And it is the square root of x sub 2 minus x sub 1 within parentheses squared plus the parentheses y sub 2 minus y sub 1, the quantity squared. So within your homework has 12 questions. So the first 6, they provide a graph in which you have to identify the coordinate points and then plug them into your distance formula and eventually come up with a single number value that is the distance between those 2 points. In the last 6 questions, 6 through 12, they give you 2 coordinate points, and then you have to plug them into this formula, and then you end up after you do all your operations, you end up with a single value. So we're going to start with questions 1 through 6, where they provide a graph. So they provide a graph, something like this, and they have a line segment with 2 endpoints. And so when you're given this graph, you have to identify the points. So in order to do that, you need to know how to identify the coordinates. We have an x-axis number line and we have a y-axis number line. So we have 2 axi, and this makes a 2-dimensional graph because we have 2 axi. And the x-axis, it moves left and right, or horizontally. Our y-axis moves up and down or vertically. So it's like having 2 number lines. So both number lines, they start at 0 here, and you have a coordinate point. So for example, A has a coordinate point where you have 2 numbers that are separated by a comma within parentheses. Okay, so our first value that is before the comma is our x value on our number line of that point. And so the x value, we always start at 0 for both of our number lines. This center point called the origin, x is 0. And then we move over to the x value of the point. So I move over 1, 2, 3, and the x value of -3 lines up with my point for x. So this is 0. When I move to the right, I'm moving in the positive direction. 1, 2, 3, 4, 5. When I move to the left, I'm moving in the negative direction. I'm becoming more and more negative. So I moved 3 units in the negative direction, so my x value on my x-axis number line of this point will be -3, because the x value lines up with that point at -3. And our y-axis, we move up from 0. Remember that our 0 is the same for both of our number lines. We're moving up 5. So I move up 1, 2, 3, 4, 5. If I'm moving up, I'm moving in the positive direction. If I'm moving below, I'm moving in the negative. So if I'm moving to the right, I'm moving positive. To the left, I'm moving in the negative direction. So I start at 0 and I move up 5. Number after the comma is my y value, and it lines up with 1, 2, 3, 4, 5. So now I have my point for A, which is -3, 5. That's our coordinate point, our location of that point on our graph. B is going to be the same way. You start at the x value. So I start at 0, and I move over 1, 2 in the negative direction. So -1, -2. So my x value is going to be -2. My y value is, I'm going to fall 1, 2, 3. So I'm falling, -3 lines up with my point. So my y value, which is the number after the comma, is going to be -3. So I have 2 points. I have A, and then I have B. Okay, so A is just -3, 5, and then you have B, which is -2, -3. And you just plug them in the formula. So I create this distance formula. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now these numbers, these sub-numbers, are the point, the x value of our second point, minus the x value of our first point. the y value of our second point minus the y value of our first point. Well, we have 2 points here, so we have to call one point 1 and point 2. It doesn't matter which one. So I'm just going to call A point 1, I'm going to call B point 2. So we know that our coordinate point is the x value before the comma is x, the number after is y. So with choosing our first or second point, like I said, it doesn't matter which one you choose. You'll end up with the same answer if you plug it into this formula. So this is my first point. I'm going to put a 1 next to y. So that's x sub 1, y sub 1. The x value of our first point, our y value of our first point. And then we have the x value of our second point, the y value of our second point. Okay, so we have our inputs here, and we can plug them into the formula. So we plug it in, and we have x sub 2, which is negative 2, minus x sub 1. So know that this minus is independent of the minus that is inside this number here. So we have to conclude the minus right there. Then it's minus negative 3 squared. And then we have y sub 2, which is minus 3, minus y sub 1, which is positive 5. That quantity squared. Just so you know, just in case, side-by-side sign rules. If you have two of the same sign that are side-by-side, it's going to reduce to a single positive sign. If you have any combination of negative and positive that are side-by-side, you're going to end up reducing to a single negative sign. So when I rewrite this and I reduce the signs, I'm left with minus 2 minus minus gives us a positive 3 squared, plus minus 3 minus positive, so minus positive gives us negative, reduced to a negative sign, squared. And so then we have to do PEMDAS, which is just the order of operation. So we deal with the parentheses first. P stands for parentheses. So we reduce our parentheses to a single number. Negative 2 plus 3 ends up just being 1, that quantity squared, plus negative 3 minus 5 gives us negative 8, that quantity squared. Okay, so we're done with our parentheses, and we move on to exponents. So 1 squared, when we have an exponent in the top right corner, we're saying that number, whatever it is, that base, multiplied by itself by as many times as the number the exponent tells us. So 1 multiplied by itself twice, 1 times 1 is 1, plus negative 8 squared, negative 8 times negative 8 is going to give us, so 8 times 8 is 64. A negative and a negative is a positive, so it's just going to be positive 64. And then this equals to the square root of 65. And that would be our final answer. Hooray. Okay, so going over a second example. So just recall from when we went over class, this whole formula is derived, it's sourced from the Pythagorean theorem. So this formula was created by its sources from the Pythagorean theorem. So going over number 2. So this is our example number 1. We're going over example number 2. We'll go over 4 of these. So we have point A and point B. So we have 2 number lines, our x-axis number line and our y-axis number line. We have to, with these types of problems, identify the point. So our number before the comma is our x value. We start at 0. We're moving to the left, 1, 2, 3, 4 in the negative direction. So this will be negative 4. Recall that 0 is the same, the origin for both number lines. Our y value is going to be 2. B, our x value is going to be 3. Our y value is going to be 2. Okay, so then we just use our formula. I have the formula up here, so I'm just going to plug my numbers in here. And I'm going to choose a point. This time I'm going to move from right to left. I'm going to choose that as point 1, this is point 2. So this will be x sub 2, this will be y sub 2, this will be x sub 1, y sub 1. Okay, so x sub 2 is going to be negative 4 minus x sub 1, which is positive 3 squared, plus y sub 2, which is 2, minus y sub 1, which is positive 2, that quantity squared. Okay, so We first reduce the signs to a single sign between each number. So we have -4 minus plus, so minus plus gives us -3 squared. And then we have 2 minus plus gives us -2 squared. Okay, so then we think about PEMDAS and we do the parentheses first. -4 minus 3 gives us -7 squared. 2 minus 2 just gives us 0. Another parentheses that we need to reduce, and we're moving left to right. Okay, so then we move on to exponents. -7, and we have it in parentheses. This is -7 squared. So we take into account the sign, the symbol, the sign. So it's going to be -7 times -7. This is opposed to if we had -7 squared and our base was not in parentheses. In that case, we would have an answer with that sign, but it would not be it wouldn't be considered in multiplying the base by the amount of times the exponent. So we're left with the negative sign at the end, and this will be -49. But because we have this base, -7 in parentheses, that means we're including the sign within our multiplication of how many times the exponent of this number and the sign. So we have -7 times -7, as opposed to 7 times 7, and then we hold the sign until the end with the base without parentheses. Okay, so this is 49, -7 times -7. 7 times 7 is 49. A negative and a negative gives us a positive in multiplication. Plus 0 times 0 is just 0. So we're left with the square root of 49 as our final answer for number 2. Okay, so I'm going to create another video to go over 2 more of these problems in which you have to use the distance formula with graphs. See you soon.